What your favorite geometry theorem says about you. Pythagorean theorem. You peaked in middle school geometry and you still get excited when you see right triangles in real life. Triangle angle sum theorem. You think 180 degrees is the perfect amount and you've definitely used this to win an argument about angles. Parallel lines theorem. You love alternate interior angles and you think parallel lines are criminally underrated. Vertical angles theorem. You appreciate simplicity and you think congruent angles across intersecting lines is elegant. Corresponding angles theorem. You understand transversals and you've definitely drawn parallel lines with a crossing line for fun. Circle theorem. You think all radii are equal and you've used this fact more times than necessary. Inscribed angle theorem. You love that inscribed angles are half the central angle and you think circles are magical. Thales theorem. You think any angle inscribed in a semicircle being 90 degrees is mind-blowing. Tangent radius theorem. You appreciate that tangents are perpendicular to radii and you've probably drawn this diagram 100 times. SAS congruence. You think two sides and the included angle prove everything and you're right about triangle congruence. SS congruence. You prefer when all three sides match because it feels more complete. ASA congruence. You think angles matter more than people realize and you love angle side angle proofs. AAS congruence. You're that person who points out this works too and everyone forgot about it. HL congruence. You love right triangles specifically and you think hypotenuse leg is underappreciated. Double a similarity. You think similar triangles only need two angles and you appreciate the shortcut. SAS similarity. You prefer the side angle side approach to similarity and you think ratios are elegant. SS similarity. You love when all three sides are proportional because it's the most complete proof. Mid-segment theorem. You think the segment connecting triangle midpoints being parallel and half the base is beautiful. Centroid theorem. Orthocenter theorem. You think altitudes meeting at a point is underrated and you've drawn this for every triangle type. Exterior angle theorem. You love that exterior angles equal the sum of remote interior angles and you use this constantly. Base angles theorem. You think isosceles triangles are special and you've definitely proven base angles are congruent. Triangle inequality theorem. You understand that two sides must be greater than the third and you've used this to prove triangles can't exist. Polygon angle sum theorem. You love that interior angles equal 180 and 2 and you've calculated this for every polygon. Regular polygon theorem. You think all sides and angles being equal is the definition of perfection. Trapezoid mid-segment theorem. You appreciate that the mid-segment equals the average of the bases. Parallelogram opposite sides theorem. You think opposite sides being equal and parallel defines parallelograms. Parallelogram diagonals theorem. You love that diagonals bisect each other and you think this proves everything. Rectangle diagonals theorem. You appreciate that rectangle diagonals are congruent and perpendicular. Rhombus diagonals theorem. You love that rhombus diagonals are perpendicular bisectors of each other. Square properties theorem. You think squares are the ultimate shape because they satisfy everything. Secant power theorem. You appreciate external segments and you've definitely used this in proofs. Arc length theorem. You love that arc length equals radius times angle in radians. Sector area theorem. You think calculating pizza slices is practical geometry. Law of sines. You prefer this over cosines and you think it's more elegant for non-right triangles. Law of cosines. You think this generalizes the Pythagorean theorem perfectly for any triangle. Heron's formula. You love calculating triangle area from just the sides and you think this is underrated. Area of a triangle. You think 1/2 base times height is the most useful formula in geometry.